The truck used in this scene is in fact real, but a pistol was used to shoot it over the wire. However, we are going to explore if it's possible to flip an 18-wheeler straight up. The truck in this film is 10,000 pounds. There's 7,000 pounds in the back and 3,000 in the front. To prove this is right, we're going to have to find the kinetic energy of the truck traveling at a certain speed. To find out if this is real physics, we're going to have to figure out the centers of gravity in both the front of the trailer and the back of the trailer. The center of gravity is the sum of the position times the mass divided by the sum of the masses. The front of the truck is 8.2 meters and the back of it would be 12 meters, with an overlap of 2.5 meters, putting the center of gravity at 6.24 meters. The SSF, or static stability factor, of this truck is 1/2 the track width divided by the height of the center of gravity. If the kinetic energy is still more than the potential energy when the rig is standing straight up, then we know that there was enough energy for the truck to flip. To find the kinetic energy, we can use the equation 1/2 mv squared. With this formula, we get an answer of 2,170.1 kilojoules. The potential energy here would equal the mass times the acceleration due to gravity times the change in the center of gravities. That comes out to 462 kilojoules, which is much less than the kinetic energy. Here Batman is trying to save Rachel from the Joker, and the Joker lets go of Rachel from a free-falling building. The question here is if Batman would have really been able to catch Rachel falling off that building. To find this out, we assume that Rachel had a velocity of 0 when she fell from the building, and because Batman was running, comparing him to one of the fastest people in the world, we gave him a velocity of 12 meters per second. For an initial height, we'll use 0.5 because it's about an average size entry awning. Rachel fell about 3.8 meters, and the movie said in 1 second. Using the kinematic equation of displacement equals initial velocity times time plus 1/2 a delta t squared, you can find out how much time it actually took Rachel. With the equation, it is found that it took Rachel 0.278 seconds to fall 3.8 meters. This does not match up with the movie because it said it took her 1 second to complete that 3.8 meters. Batman may have been able to catch her, but because the movie's not reliable on timing, it is hard to say if he actually could or couldn't have. With Batman's greater initial velocity and the acceleration due to gravity, it would make sense that he would be able to catch Rachel. It's given to us that the mass of Spiderman and Venom is 75 kilograms. It took them 22 seconds based on the time in the video. Their acceleration is 9.81 meters per second squared, that's the acceleration due to gravity, and the height of the building is 80 stories. One story equals 3.048 meters, which gives you 243.84 meters. In this, we're going to look for the initial velocity of Spider-Man and Venom, using the law of conservation of energy. From this velocity, we're going to use the kinematic equation that delta y equals 1/2 a delta t squared plus initial velocity times time. This equation gave us a displacement of 850.74 meters, meaning that the physics proved this movie wrong because Spider-Man would not be able to fall 850.74 meters because the building was only 243.84 meters high. Here in Inception is an example of good dynamics. Using the law of inertia, saying that an object at rest stays at rest, and the centripetal force, we are able to prove that this is good dynamics. In this scene, you can see that the person moves left while the car moves right. The body here is in motion and tries to stay in motion even throughout the entire spin of the car. As the car turns due to inward centripetal force, the person still remains at rest, going straight, given the feeling of being pushed outward because the forces are in opposite directions.